Hello, I'm Mr. Bob, and welcome to my Algebra 1 review series. This video covers Chapter 10, Section 6, titled Completing the Square. By the end of this video, you will have reviewed recent lessons describing the methods of solving quadratic equations by completing the square. You will review finding n to complete the square. You will solve ax squared plus bx equals c. You'll solve ax squared plus bx plus c equals 0. Finally, you will have reviewed the solving of a real-world problem requiring the solution of a quadratic equation using completing the square. If you'd like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to my channel if you find the video to be helpful. Thank you. Okay, before we get going, we'll discuss a definition. Completing the square. You can change an expression like x squared plus bx into a perfect square trinomial by adding b divided by 2 squared, or the quantity b divided by 2 squared, to the x squared plus bx equation. This process is called completing the square. The process is the same whether b is positive or negative. Objective 1, solving by completing the square. To explore this method algebraically, consider the equation below. In a perfect square trinomial with a equals 1 and c must be half, or the square of half of b. So we look at it. We start off with, right here, with the binomial term, x plus 4, and we square it. So that's our squared term, right? Our perfect square. So when we multiply the 2x plus 4 terms out, we get a trinomial. And when you do that, you look at the mathematics here and you end up with an x squared and 4 squared and 4x's. And that'll end up being x squared plus 8x plus 16. So now, how do we get the perfect square? We'll take a look. So if we take the 8, and we divide it in half, we get 8 divided by 2. That equals 4. Well, 4, if you take that 4 now and you square it, you're going to get 16. And that is the perfect square trinomial. So it's half of the b term squared. So that's what when you want to complete the square, you have to do this process of taking the b term, cutting it in half, squaring it, and then adding it to both sides of your equation, of course. Don't forget that. So you can change an expression like x squared plus bx into a perfect square trinomial by adding half of the b term squared, b divided by 2 squared, to the expression x squared plus bx. This process is called completing the square. The process is the same whether b is positive or negative. So here in example 1, they're asking us to find the n that's going to complete the square. So let's find the n. It says find the value of x such that x squared minus 12x plus n is a perfect square trinomial. The value of b in the expression x squared minus 12x plus n is minus 12. Here's our b value right here, minus 12, right? The whole thing, minus 12. Okay, so the term to add to the x squared minus 12x is minus 12 divided by 2 squared. Well, of course, you know that's going to be a positive, but we want you to keep that negative in mind here because you're going to use it anyways in the future. So that's what you're going to add to both sides, or 36 in this case, because 12 divided by 2 is 6. 6 squared is 36. It's a positive 36. So that new equation would be x squared minus 12x plus 36. Okay. Okay, example 1, check your understanding. Find n. They'd like you to find the value of n such that x squared plus 22x plus n is a perfect square trinomial. Go ahead and try it on your own. Come on back, and when you're done, we'll do them together. Okay, we're going to assume you've done all that work and you're back, and we're going to go and look at this and try to come up with what is the value of n. Well, let's just start off by writing. I'm going to say x squared plus 22 x plus something, I'm not going to write the n, plus something is going to be equal to probably 0 is what it'll probably end up being, but It could be any number out there, literally, but that's neither here nor there. In fact, I'll take that off just because I don't want to confuse. Let's just take that off, and I'm going to put a question mark right there. How's that? A question mark. We don't know what it's going to be equal to. However, they want us to find n. So how do we do that? We're going to take 22, which is the b term, the entire term, plus 22. So we're going to say plus 22 divided by 2 squared. And that equals 22 divided by 2 is 11. 11 squared is 121. So now the n is equal to n, or I'll say n is equal to, okay, I'm going to get rid of that. So now we have it. So now the n value is going to be 121. That's now completed the square. Okay? Okay, example 2, solving x squared plus bx equals c. Solve the equation x squared plus 9x equals 136. So how are we going to do this? 2 steps we've got outlined for us. First, write the left side of x squared plus 9x equals 136 as a perfect square. Okay, that's the first thing we have to do. So we're going to write out the very beginning here. And when I write down this equation here, and what we're going to do is we're going to look at this and say, we need space, because we need to get the c term, if you will, in. So I wrote it out automatically with space. And now you can see that what you're going to need as you're writing these things out by hand, you're going to take, to find the n, you look at the b term. And by the way, you look at the entire b term. It's plus 9. And they want you to take half of that, which is 9 divided by 2. Right here you see 9 divided by 2. And then they want you to square it. And that is your c term. That's this square we're talking about. We're completing this perfect square by adding 1/2 of b squared. And when you add it on one side, you add it on the other side. It's on this side, on the right-hand side, along with the left-hand side. So now you have it, you're ready to go. Now you can take and you can factor this perfect square trinomial into x plus the quantity x plus 9 over 2 squared. And that's equal to 544 fourths plus 81 fourths. And the way we got 544 fourths is we had to get a common denominator. Well, after you square this term here, our 9 halves squared, you're going to get 81 fourths. Well, now you need a common denominator, so you're going to divide or multiply both the top and the bottom by 4. So you're going to get 4 times 136 divided by 4, and then you have a common denominator, and 136 times 4 is 544. So now you have 544 fourths plus 81 fourths, and now you add those together, and that adds up to 625 fourths. So now the equation in its entirety now looks like the quantity x plus 9 halves squared is equal to 625 over 4. So now we go to step 2. It says solve the equation. So what we're going to do is to solve it, we're going to have to take the square root of both sides. So the term on the left is the squared term, and the term on the right, we're going to have to take the square root of it. So when we take the square root of the left-hand side, you're left with x plus 9 halves. This is the square root of x plus 9 halves squared. And then when you do that, then you're going to take the square root of the right-hand side. We're just going to put the square root on it, right? And take plus or minus this value. And now you're going to have to calculate, somehow, we're going to have to calculate the 625 fourths. But when you do that, if you take that square root of that, you're going to end up with x plus 9 halves, that's from the left-hand side, is equal to 25 halves. Because 625 is 25 times 25. And 4 is 2 times 2, so it's 25 halves. So now when you take it to the final step, it's going to be, it says x plus 9 halves equals 25 halves, or x plus 9 halves equals negative 25 halves, because it's plus or minus. You have to do both of them. You have to do them both. You can't just do one. You have to do them both. And then after you've done that, you can basically move on to simplifying. You're going to you're going to get the x by itself, so you're going to add subtract 9 halves from each side. Okay, and then once you do that, you'll come down here, you see you've got 25 halves minus 9 halves. So you're subtracting the 9 halves. Basically, then once this is done, the x is by itself. 9 halves minus 9 halves is 0 halves. And 25 halves minus 9 halves is 16 halves right here. Or the other term is right here with the one with the negative 25 halves. So we've gotten rid of the 9 halves on the left-hand side. On the right-hand side, we have negative 25 halves minus 9 halves. And when you put those together, you have negative 34 halves. And that's both of these are simplified, except for the fact that we got 16 divided by 2 is 8. So x is equal to 8, or negative 34 divided by 2 is negative 17. That's the solution. Okay, example 2, check your understanding. You can stop the video and try this one. It's the same as the previous slide. When you get back, we'll do it together. Okay, I'm assuming you've done that and you're back. So now let's go. So I'm going to start off by writing the equation m squared minus 6m plus the number we're going to add. I'm going to leave a space so that we can stick it in here, 247. Okay, now we have to find out what is the n term. The n term is half the b term, which is minus 6, negative 6, divided by 2, that's half of it, and squared. And once you do that, 36, okay, this is 36, and this is 4, and 36 divided by 4 is what? 9. But it's positive. It's equal to 9, because this negative term squares also. It becomes 9. So it's plus 9. And we add this 9 to both sides. Now that we have that, we can move on to getting the sum of two squares over here. So we have, here's the square, and it's m. And what you're doing is you're putting in here is 3, right? You're putting in not the square, but the unsquared piece, or the 6 divided by 2. So that's equal to 9 minus 3. You have to carry your negative sign here. Negative 3, and that equals 247 plus 9 is 256. So now we have to move on to squaring both sides of the equation. Well, this will easily square because it's a perfect square. Okay, so it's going to be m minus 3, and that's going to be equal to the plus or minus the square root of 256. Well, now we have m minus 3 is equal to plus or minus square root of 256 is 16. Solve for m. M is equal to 3 plus or minus 16. And that's going to give us, m is going to be equal to what? 3 plus 16 is 19. And m is going to be equal to 3 minus 16 is going to be minus 13. There's your two answers, 19 and minus 13. Example 3, solving x squared plus bx plus c equals 0. So now what you're going to end up doing is to complete the squares, we're going to move the c term, right? Remember that? So to solve an equation in the form x squared plus bx plus c equals 0, you must first subtract the constant term c from each side of the equation. Okay? Because so the equation is x squared minus 20x plus 32 equals 0. So the first step we're going to write here, we're going to have x squared right here, x squared minus 20x plus 32 minus 32 equals 0 minus 32. So now the 32's cancel, and we have x squared minus 20x equals negative 32. So now we get the n term. We get the n term by taking the b term, negative 20, dividing it in half, so now you're going to have negative 10, negative 20 over 2 squared. So it comes up to 20 halves squared. I wrote it 20 halves. You can do it that way, or you could have written 10. Okay, squared on both sides. So then once we do that, 10 squared is 100. So I have x squared minus 20x. Here's the beginning part. X squared minus 20x. We're still dealing with that. And now we're moving on the new c term, which we have 100. 20, half of 20 is 10. 10 squared is 100. And that 100 is on both sides. And we added a 32 to start with. Okay? So we still have the negative 32. So the answer, x minus 10, because that's what you put back in for the sum of two squares, the difference of two squares, x minus 10 squared equals 68. 100. That should be a plus. I'm going to change it after we stop the video. It should be plus 100 over here. Sorry. It's 68. So now we're going to go ahead and we're going to take the square root of both sides, which is over here, solving the equation. So you have x minus 10 squared is equal to 68. So we're going to take the square root of both sides, and we're going to end up with x minus 10 equals plus or minus 825, 8.25, because you can use your calculator to get the square root, okay, 825. So then once you have the 825, you can say x is approximately 825 plus 10, or x is negative 825 plus 10. And when you add them to 825 plus 10 is 1825, and negative 825 plus 10 is x is 1.75. Okay, example 3, check your understanding. There are two problems, so we're going to do it on two slides. Go ahead and stop the video, and or not stop it. You can stop it, whatever, try these problems out on your own, and when you come back, we'll do them together. Okay, now I'll assume you're back. So let's try it. So we're going to start off with we have to move the c term, to the right-hand side to make room for our new n term. So we're going to do that. We're going to say x squared plus 5x plus, because I know it's going to be a plus term we're going to add. And then I'm going to say equals, and it's going to be equaling to what? Negative 3, because I moved the 3 over to the other side. I did it all in one step here, right? Added a negative 3 to both sides. So now that I have that, I can put my new n term in here. So that's 5 divided by 2 squared. So I can write that in here. I can say 5 halves squared. And then I have to add it to both sides. So I have to say plus 5 halves squared. And then I'll just go ahead and go on from here. So then I can get the sum of two squares here, sum of squares. So I'm going to say x is the x plus 5 halves squared is equal to minus 3, and it's plus what? It's plus 25 fourths. 25 fourths, and I'm going to convert that, so I'm going to say is equal to, carrying on here, minus 3 plus 25 fourths ends up being 625, 6.25. So now we're going to have the 6.25 plus the 3, or minus the 3 at this point. So I'm going to rewrite the whole line here, and it's just so it's going to be the quantity x plus 5 halves squared is equal to 625 minus 3 is 3.25. Okay, now we have to take the square root of both sides. So square root of the quantity x plus 5 halves squared is equal to plus or minus the square root of 3.25. Okay, and when we take the square roots of both sides, we get x plus 5 halves is equal to plus or minus, and the square root of 325 is 1.80. So we're almost there. So now we're going to move the 5/2 to the right-hand side to get solve for x. So now we're going to have x is equal to minus 5/2 plus 1.80 and or minus 5/2 minus 1.80. And if we do that, what is 5/2 is 2.5. I think we can say that. So we can say that x is equal to minus 2.5 plus 1.8, or we can say minus 2.5 minus 1.8. I'll say 0. I'll put the 0 on because they want it in hundredths. And since they do, so this one here, the one where we subtract, comes up with x equaling negative 0.70. And or, the positive version, it's a negative version, but it's adding them, the negatives together. It's negative 4.30. Okay, on to the next slide. Okay, example 3, it's the second problem. Check your understanding. Go ahead, give it a shot. It says round to the nearest 100th. I'll wait for you. Okay, now I'm sure you're back, so let's go ahead and do it. First thing I'm going to do is we're going to move the 16 to the other side of the equation. So it's x squared minus 14x plus something. I'm going to leave a big hole so we can write it in, equals negative 16, because we subtracted 16 from both sides. Now we need to find our new n term to put in the equation, and that happens to be 14 divided by 2, which is 7, squared is 49. So I'm just going to write a 49 right here, and a plus 49 on this side. And now when I do this, I'm going to get x minus 7, that's 14 divided by 2, squared, is equal to 33. Now we're going to take the square root of both sides. So when I do that, we're going to get x minus 7 squared over here, plus and minus the square root of 33. And you're going to take this, and now it's going to be x minus 7 is equal to plus and minus 5, what is it, 5.74. Okay, so now we're going to solve for x. X is equal to 7. We added 7 to both sides. So we got rid of the negative 7 on the left and put a positive 7 on the right. Plus and minus 5.74. And when we solve this out, x can be either, I'll do it right here. Well, I'll do it right. X can be equal to 7 plus 574, which is going to be 12.74, or x is going to be equal to 7 minus 574 is going to be 1.76. No, not 76, 26. Sorry, I have to do this over again. I'm going to delete that. Put that right here. Sorry, 26. I got carried away with the 7s from the line above. Okay? And that's to the nearest hundredths. Okay, it's time to do our real world problem here for example 4. Let's read what's on the picture there. It says, suppose a woodworker wants to build a tabletop like the one shown at the right. If the surface area is 26 feet squared, what is the value of x? So you see the tabletop is broken into x's and 1s, and the length is x plus an x plus an x plus 2 1s, and the width is an x and a 1. So now you have an idea that it's x plus 1 is the width, and 3x plus 2 is the length. And they add that up, and you can see it. 1x and a 1 is x plus 1, and for the length it's x plus 1 plus 1 is 3x plus 2. Length times width is the area. So our new formula for this tabletop is going to be 3x plus 2 times x plus 1 equals 26. So let's solve it. So I wrote over here on the upper left, I rewrote this information. 3x squared plus 2 times x plus 1 equals 26. I multiplied it out to get my trinomial, because I now have a trinomial that I can clear the c value from. So I have 3x squared plus 2x plus 5x plus 2 equals 26. Now I'm going to rewrite the equation so that I have it in the form x squared plus bx equals c. I moved the c to the right side. So given that, I have 3x squared plus 5x plus 2 equals 26. I'm going to subtract 2 from both sides. So I'm going to have 3x squared plus 5x, no more c term, plus 24 because I subtracted 2 from the 26 and got a 24. So now given that, the other problem we have is that the a term, right here, the 3, is not a 1. It must be a 1 for us to complete the square. So now we have to divide everything in this equation by 3. And when you do that, you'll get x squared plus 5/3 x equals 24 divided by 3, 8. Now we're ready to start rolling here. Complete the square. To complete the square, I have x squared plus 5/3 x. I have a space equals 8. So we have to fill that space with something. What do we fill it with? We fill that space right here with half the b term squared. And half our b term is 5 divided by 2 times 3, because it's half. So it's 5 divided by 6 squared. 5 divided by 6 squared is 25/36. 5 squared over 6 squared. And that is equal to 8 plus 25/36, because we had to add it to both sides. So now we have our new square term here, right? We have our sum of two squares. We have x plus 5/6 squared. And that's equal to 288/36 plus 25/36. Well, wait a minute. Why do I have 288? Where did I get the 288/36 from? Well, I got that because we didn't have a standard denominator. We had 8, and we had to add 8 plus 25/36. So I needed to get the 8 over 36. And in order to do that, I had to multiply the 8 times 36 so I could divide it by 36. 36 divided by 36 is 1. So when you multiply 8 times 36, it's 288/36 plus 25/36 gives us 313/36. So at this point, we are now ready to take the square root of both sides. And if we do that, we'll get on the left-hand side, we'll get x plus 5/6 plus or minus equals plus or minus the square root of 313/36. So now we're going to solve the equation. So right here, x plus 5/6 is equal to plus or minus the square root of 313/36. Well, going to the next line, x plus 5/6 is approximately equal, because we're going to take the square root of this number on a calculator, and we're going to get plus or minus 2.95. We used a calculator to get that. It's approximate. You can't divide that and take the square root and get any number that doesn't end a million digits, a zillion digits. It's infinite. So now that we have that, we can now solve what the value is here. It's approximately equal to, because this is plus or minus, right? So x plus 5/6 is approximately equal to 2.95. Or x plus 5/6 is approximately equal to minus 2.92. Okay, so now we can get the x by itself. And by doing that, we're going to subtract 5/6 from each side. And when we do that, 5/6 is 0.83. So we're going to subtract 0.83 from both sides of the equation. And when we do that, we're going to get x is approximately equal to 295 minus 0.83, which is x equals 212, 2.12, or we're going to get x is approximately equal to minus 295, because it's plus and minus, right? Minus 83, which is going to be minus 3.78. So you can't have a negative length. This x value here cannot be used because this is a table in the real world, and it has to have a positive dimension. It can't have a negative dimension. So the only dimension we can use is the 2.12. And so we can say the value for x is about 2.12 feet long. Okay, example 4 for check your understanding. There are two problems. It's going to be on two different slides. So it might take up more space than I use normally for, we'll see. So I just wanted to make room. So it says solve each equation and round to the nearest 100th. So our equation is 4a squared minus 8a equals 24. So you know we're going to be completing the square to solve this. So right off the bat, I'm going to rewrite this. And I'm going to rewrite it like I did the other one. I'm going to say 4a squared minus 8a plus, and I'm going to leave a big space, equals 24. And now I'm going to do two things. First of all, I'm going to go ahead and I'm going to divide everything by 4, because we have to get the a term equal to itself. So I'm going to divide this side, this by 4, this by 4, and the 24 by 4. And I'm going to get a squared minus 2a plus something equals 6. So what is the term we're missing? Well, the term we're missing is half the b term squared. The b term is negative 2. So negative 2, half of that is negative 1. Negative 1 squared is 1. I'm going to add a 1 to both sides. Now that I've done that, I can rewrite this as the quantity a minus 1 squared. And that equals 7. Now it's time to take the square root of both sides. Taking the square root of both sides, I'm going to get a minus 1 is equal to plus or minus the square root of 7. And that's not a simple number. The square root of 7 ends up being, according to my notes, where is the square root of 7? 3. It's square root of 7. Is 265. Sorry it took so long to find that. I had it written down and then I couldn't find it. Is equal to 265. So that's equal to plus or minus 2.65. Get that point right there. Okay, 2.65. So I have a negative. So now what I have a negative 1 here. I'm going to add a 1. So that'll zero this out. A will then be equal to 1 plus 265, 2.65, and a will be equal to 1 minus 2.65. And what are those equal? So 1 plus 265 is going to be equal to 3.65. And minus 265 plus 1 is going to be equal to minus 1.65. There's our two terms, 365 and minus 165. 3.65 minus 1.65. Okay, let's move on to the next one. Okay, doing our second problem now for example 4. Go ahead, stop the video, do the work, come on back, and we'll do it together. Okay, I'm assuming you're back. Let's give it a try. So right off the bat, we can see that it's not in the form we need. There's two things that we need to adjust. One, we need to move the negative 15 to the right side of the equation because we need a blank spot for our new c term. And the a term of the n squared cannot be a 5. It has to be a 1. So we have to divide everything by 5. So starting right off the bat, I'm going to say 5n squared minus 3n minus and plus 15 is 0. I'm going to say plus. I'm going to leave a big space. 10 plus 15 is 25. So now I've taken care of moving the 15. I'm going to divide everything by 5 to get the a term at 1. So divide by 5, divide by 5, and divide 25 by 5. And I'm going to have n squared minus 3/5 n plus equals 5. Now I have the room right here to put my n term. And I get the n term by taking 3/5 and dividing it in half, which is 3/10, and squaring it. And when I do that, I'm going to get 9/10 squared is 100. So 3/10 is 9/100. And then I touched it. I'm going to get rid of that little guy right there. Okay. So now we have it, 9/100. And I have to add that to both sides. 9/100. Okay, without going any farther into the process, well, I will. So I'm going to take now and finish there, completing our square. We're going to create the difference of two squares. We're going to have the quantity n minus 3/10 squared is equal to, well, in order to add these two terms together, I have to have the 5 has to be over 100, so it's 500 hundredths. I have to multiply the top and the bottom by 100. So that's going to be 500 100ths plus 9 100ths. And if I just continue on right here, that'll be 509 100ths, or one last step, 5.09. Okay? So now that we have that, we can now take the square root of both sides. So taking the square root of both sides gives me n minus 3/10 equals plus or minus the square root of 5.09. So taking and changing my 3/10 to a decimal, that's going to be 0.3. So I can say that n minus 0.3, okay, is equal to plus or minus the square root of 5.09. Well, I'm going to, like I said, I'm going to convert that to 0.3. And so the new equation is going to be n, I'm going to get rid of the 3/10 by adding 3/10 equals 0.30 plus the square root of 5.09, and n equals 0.30 minus the square root of 5.09. Well, the square root of 5.09 is equal to, I'm going to write it right here, 2.256. 256. That's the square root. So it's going to be plus and minus that number. So carrying it over here, I'm going to say our new number is going to be n is equal to 0.30 plus 2.256, and n is going to be equal to 0.30 minus 2.256. And when we do the math on that, we're going to find out that this is equal to 0.3. You have 2.256 plus 0.3 is going to be 2.5 2.56 equals 2.5. I'm just going to round it to 6. 5, because the 5 here rounds to a 6. And then for the next term, with the negative 2.256, I'm going to subtract 3/10 from it, and we're going to end up, and it's a negative 2.256. It's going to be equal to negative 1.96. And there's our solution. N is equal to 2.56, or N is equal to minus 1.96 rather.